Hello everyone. So last time we talked about solving basic equations utilizing addition and subtraction. And in this section, 4.3, we want to talk about solving basic algebraic equations using multiplication and division. Okay, so again, before we even start talking about how to solve the equations, let's practice a little bit about translating a sentence into an equation. So I'll say, again, we want to be able to translate a sentence into an equation. Okay, it's just that the difference is these are going to involve multiplication and division, where the other ones involved addition and subtraction. So for example, let's say you're told 2/3 of a number, and we'll call it, let's say a number x, is 20. So how do I translate that into an equation? Okay, so 2/3, I can just write down 2/3. Remember of, right? Of means multiplication. So this is going to be times x is equals, and then 20. So that would be the equation. 2/3 x equals 20. And I don't even need to write the dot there, right? If I just write 2/3 next to the x, that's fine. That implies 2/3 times x. It implies multiplication. Okay, another example. Let's say we're told a number z. So if I didn't give you that, you could just use any variable you want, but we're going to call it z, divided by 8 is equal to 8/3. Okay, so I start with a number z. Now in an equation, divided by 8 we write as a fraction, right? So over 8 means divided by 8 is equal to, is the equal symbol, and then on the right hand side I have another fraction, 8/3. So that would be the equation, z over 8 equals 8/3. Here's another example. Let's say you're told the product of 8 and an amount is the same as 32. Okay, so our unknown here, right, is an amount. Give that a name. What variable do you want to use? Maybe let's call it y, let's say. Okay, so the product means multiplication, right? So the product of 8 and y, well, I can write that as 8y. Remember, that means 8 times y is the same as, is another way of saying equals 32. So that would be my equation. 8y equals 32. Or 8x equals 32, or 8a equals 32, right? Doesn't matter what we use for our variable name. Okay, now how do I solve these types of equations? By isolating the variable again. Okay, so to solve these equations, we again want to isolate the variable. Basically, we want to find an equivalent equation, right? One that has the same answer, but where the variable itself is by itself. It's isolated on one side, because then it's easier to read off the answer. Okay, so here's the first example. Let's say let's say I want to solve n divided by 9 is equal to 3, right? I want to solve that for n. Okay, since n is being divided by 9, how do I undo that? Remember, the goal is to get n by itself. And by n by itself, I mean I want a 1n, right? I want like 1n, which is n, is equal to some value. And then I can read off the answer. So since n is being divided by 9, to undo the division, I can multiply by 9, right? So I can multiply the left side by 9. But whatever I do to one side, just like before, we have to do the other side, so I have to multiply the right side by 9. So here, look what happens, right? If we look at this more carefully, 9 times n over 9. Why does that work? Because this is 9 over 1 times n over 9. If I multiply those fractions, see how the 9s, first of all, we can cancel them, and I get n over 1, which is n. So this just gives me n on the left-hand side, which is exactly what I want. I wanted to isolate the variable. The right-hand side, I have 9 times 3, which you can work out, is 27. So that's my answer. Once I've isolated the variable, I can read off the answer. N must be 27. Okay. How do we know if this is true? Well, remember, you could always plug it back in to the original equation where I have an n, plug in 27. 27 divided by 9 is 3. 3 equals 3. Yep, it checks. So that is the correct answer. N is equal to 27. Okay. Let's say I want to solve 5x is equal to 125. Okay, so I'll write it down again here. 5x is equal to 125. So now, again, my goal is to get 1x, or x by itself. It's being multiplied by 5, right? So how do I undo that? Well, I can divide by 5. Some people say you could also multiply by 1/5. That's also true. But for now, it's easier just to think about it as you're dividing by 5. But whatever I do to one side, I have to do to the other side. So look what happens here. The 5's cancel, right? That's what we wanted by design. So we're just left with x. There's a 1 there, but we don't ever write the 1 there. Equals, and in 125 divided by 5, you have to work this out. This is going to be 25, right? 2, and then 5 goes into 25 5 times. So x equals 25, and that would be the solution. Okay, and again, you could, if you really wanted to, let me just show you. Dividing by 5 is equivalent to multiplying by 1/5. I could also say, oh, if I multiply the left-hand side by 1/5 and the right-hand side by 1/5, that will also work, right? Because on the left-hand side, I have 1/5 times 5x over 1. See how the 5's cancel? And you're just going to get x over 1, which is x. So you've isolated the x. And the right-hand side, you have 1/25 or 125 over 1 times 1/5. If you want, you can even simplify here, right? 5 goes into 5 once. 5 goes into 125 25 times. So you have 25 times 1 over 1 times 1, which is 25. So we get the same thing. X is equal to 25. So dividing by 5 is really equivalent to multiplying by 1/5. But I think it's easier just to think of it as division, right? X is being multiplied by 5, so I want to divide by 5 to undo that multiplication. Okay. Some books, when you get into Algebra 1, they will talk about like the multiplication rule, where you always want to multiply both sides of something. So you would think of it as multiplying by 1/5, but that's really the same as dividing by 5. It's just easier to think of it as dividing by 5. All right. What about this? Let's say I want to solve 0.5a is equal to 7.5. Okay, so again, the a is being multiplied by 0.5, right? How do I undo that? Well, I can divide by 0.5. That'll give me 1a, right? These will cancel and I'll get 1a. But whatever I do to one side, I have to do to the other side. So I have a on the left-hand side. The right-hand side, you're going to have to work this out, right? Just do long division here. So remember, we move the decimal point so that in the divisor, it's a whole number, right? Move it all the way to the right, and then I have to move this one place in here, same number of places. Then 5 goes into 7 once. Subtract, bring down to 5. 5 goes into 25 5 times. So it looks like A is going to be equal to 15. And that would be the answer. And you could check it, right? You could plug it back in. If you multiply 0.5 times 15, you're going to find you get 7.5. Okay, what if we have a fraction? What if we want to solve this problem? Solve 3/7 t is equal to 15. Okay, there's a couple of ways I could do this, right? There's a few ways you could do this. Remember, whenever you multiply a fraction by its reciprocal, remember that's always equal to 1, right? Like if I multiply 3/7 times its reciprocal, remember reciprocal, we flip the fraction, we exchange the numerator and denominator, so this would be times 7/3. And notice here, right, the 3's cancel, the 7's cancel, and you're going to get 1, right? 1 over 1, which is 1. So to get a 1t there, one way of solving this is like, I could say, okay, let me just multiply both sides by the reciprocal of 3/7, which is 7/3. And then, but I have to do both sides, right? Also on the right-hand side. If you want, you can think of 15 as 15 over 1. So then, on the left-hand side, right, these cancel now by design, and I get t. And the right-hand side, I can work this out. 3 goes, in fact, we can simplify a little bit, right? 3 goes into 3 once. 3 goes into 15 5 times. 7 times 5 is 35 over 1 times 1, which is just 35. So t is equal to 35. How do we know if that's true? You could plug it back in, right, to the original equation. Here, let's do it. Let's check it. So 3/7, this will be a check. 3/7 times 35, does that equal 15? Okay, so let's first of all multiply 3/7 times 35. Think of it as 35 over 1. 7 goes in, right? 7 goes into 7 once. 7 goes into 35 5, so we can simplify. And then 3 times 5 is 15 over 1 times 1, so that's 15. So here we have 15 equals 15. That checks. Okay? That's probably the easiest way to solve it. The other way that you could solve this problem, so I'll say, or, if you wanted to do it this way, is you could say, let me write down the original problem again. It was 3/7 t is equal to 15, right? Since t is being multiplied by 3/7, you could say, well, why don't I just divide by 3/7, right? And that will give me 1t. And you could do that. You could say, okay, divide by 3/7, but whatever you do on one side, I have to do to the other side. So on the left-hand side, these cancel, and I get t. So this is going to be t. On the right-hand side, I have to do some work, right? I have 15 divided by 3/7. But remember, 15 you can write as 15 over 1 divided by 3/7. And if you go way back to module 2, right? How do I divide fractions? Well, the first fraction stays the same, like the dividend stays the same, and I multiply by the reciprocal of the divisor. I have to multiply and flip the divisor. So 3/7 becomes 7/3. And of course, if you work this out, this is 1, this is 5, this is going to be 35. So t is equal to 35. So it's the same thing, right? Dividing by 3/7 is ultimately the same as multiplying by 7/3. And remember, the first way we solved it is we multiplied by the reciprocal, which is 7/3. That's probably the easiest way to solve these types of problems. Okay, here, let's do another one of these with fractions. Let's say I have 4/9 is equal to 2/3 a. I'm going to solve that for a, okay? Again, if you don't like the variable on the right-hand side, you can always move it to the left-hand side. right? If these are equal, it doesn't matter what side I write the expressions on. So I can switch the sides. That's fine. So let's see. We want to get a by itself, right? Right now it's being multiplied by 2/3. So I have a choice. I can either divide by 2/3, right? Divide both sides by 2/3, or this is equivalent. I could multiply by the reciprocal of 2/3, which is 3/2. And maybe that's the easiest way to do it. Let's just do it that way. So since a is being multiplied by 2/3, to get a 1 there, I'll multiply by 3/2. And here I'll also multiply by 3/2. So these cancel, right? I have a, which is what I wanted. And the right-hand side, I can do a little simplification. 2 goes into 2 once, 2 goes into 4 twice, 3 goes into 3 once, 3 goes into 9 3 times. So this is going to be 2 times 1, which is 2, and then 3 times 1 is 3. So it looks like a is 2/3. Okay, can we check it? Sure, we could plug it back in, right? So let's do a little check here. Let me go to the original problem. I have 4/9 equals 2/3. I'll put a question mark here because I'm checking it. Times a, but we just found that a is equal to 2/3. Right? Hopefully. Let's check it. So that's 4/9. So right-hand side, remember, we can't really simplify, so we multiply numerators, right? 2 times 2, that's 4, and then denominators. So 4, and then 3 times 3 is 9. Yep, that's equal, so that checks. So a equals 2/3 is our correct answer. Right, we checked it. Okay, let's do a couple of problems now where we have to translate into an equation first and then solve the equation. Okay, so I want to do a couple of problems where we want to translate into an equation, then solve. Okay, so let's say we're given 1/3 of a number is 16. We want to solve that. Okay, so again, we have choices, right? A number, what do you want to call it? I don't know. Let's just call it x, I guess. So 1/3 of a number means 1/3. Remember, of means multiplication, so 1/3 times x, so I can write it as 1/3 x, is equals 16. Okay, how do I solve this? Well, I want to get rid of the 1/3, right? I want to get a 1x. I'm going to isolate the x. I can do that by multiplying by the reciprocal. If I multiply by 3, right, you can think of it as 3/1, then that will get rid of the 1/3. It'll make it into a 1, right, when I multiply. So I've isolated the x. I have x by itself. And the right-hand side, I just have to do 3 times 16, which is 48. And that's my answer. So x is equal to 48. And it makes sense, right? 1/3 of 48 is 16. Okay, another example. Let's say an amount divided by 14 is equal to 1.5. We want to find the amount. Okay, so again, we're free to choose our variable names. Let's call it, I don't know, let's call it y. So an amount we're going to call y. So y divided by 14, I can write that as y over 14, is equal to, so equals, and then 1.5. So that's our equation, right, that we want to solve. First thing I would do is convert the mixed number into a improper fraction, right? So 2 times 1 plus 1 is 3 over 2. And then how do I get 1y? Right now it's being divided by 14. I can multiply by 14, right? If you want, you can think of this as, this really means 1/14 y, right, is equal to 3/2. So I would multiply 1/14 by its reciprocal, which is 14. And then whatever I do on one side, I have to do it to the other side. So I just multiply both sides by 14. So I get these cancel, and I'm going to get y is equal to, here I can simplify a little bit, right? 2 goes into 2 once, 2 goes into 14 7 times. So I have 3 times 7, which is 21, over 1 times 1, but that's just 21. So it looks like the answer is 21. So y equals 21. Okay. Okay, here's another example involving a word problem, right? An application. So this problem says one plan offered by a long-distance phone service provider charges $0.07, which is the same as 7 cents, right, per minute for long-distance phone calls. A customer using this plan was charged $22.26 for long-distance calls this month. How many minutes of calls did she make? Okay, so the thing that we're looking for, right, the thing that we want to find is how many minutes of calls did she make? Let's create a variable name for that unknown. Maybe, let's just call it x in this case. So we'll let x equal the number of minutes. Right, so that's our unknown, right? How many minutes of calls? So x is our number of minutes. Now we need to come up with an equation that involves x that we can solve. Well, if we think about this, right, the provider charges $0.07 per minute. So the total amount of money that's going to be paid is going to depend on the number of minutes, which is x. So if you think about it, right, if I multiply 0.07, I'll even write the units here, dollars per minute times x minutes, that's got to equal the total amount of money that the customer paid, right? Which is $22.26. So really that's the equation. It's simply going to be 0.07 times x, so I can just put an x there, equals 22.26. Okay, so how do we solve this equation? Well, since x is being multiplied, I'll write it one more time here. Since x is being multiplied by 0.07, how do I undo that? Well, I can divide, right, both sides by 0.07. So that'll cancel out. I'll get 1x, which is x. But whatever I do to one side, I have to do the other side. So over on the side here, we can divide this. Remember, I have to first move this 2 places, so I need to move this decimal point 2 places, so it's going to pop up there in the answer. And then I would divide this out. See, 7 into 22 is what? 3. So this would be 21. Subtract, bring down the next digit, which is a 2. 7 to 12 is once. 1 times 7 is 7. Subtract, right? So 12 minus 7 is 5. Bring down the next digit, which is a 6. And then 7 to 56 is 8. 8 times 7 is 56. Subtract 0. So that's my answer. So this x is equal to 318. But remember, it has units, right? It's minutes. It's the number of minutes of calls. So that's our solution. X is 318 minutes. Okay, here's another question. It says, a sales representative invested $5,500 of his sales bonus in the stock market. And that amount, the $5,500, represented 1/3 of his total sales bonus. What was his total sales bonus? Okay, so again, what are we looking for? We're looking for the total sales bonus, right? So let's give that a name. Let's let, maybe we can call it X again, but maybe B for bonus, right? So let's let B represent the total sales bonus. Okay, now we need to translate, right, the rest of this into an equation. So we're told that the 5,500, I'll write it this way, 5,500 is equal to, it represents, right, so it's equal to 1/3 of his total sales bonus. Well, we just call the total sales bonus B. Remember, of means multiplication. So if 5,500 represents 1/3 of his sales bonus, then this has got to equal 1/3 of B, but then I can write that as 1/3 times B. Remember, of just means multiplication. So really this is just 1/3 B. Okay, which again I could write this way if I wanted to. Doesn't matter what side of the equals I put everything on. I can change it. They're both equal, right? So how do I solve this for B? Well, I want to isolate the B, so I need to get a 1B. Right now it's being multiplied by 1/3. I could divide by 1/3, or even easier is just multiply by the reciprocal, right? If I multiply by 3/1, then whatever you do to one side, I have to do the other side. You can think of this as over 1 if you want. So this now cancels by design, right? Any fraction times its reciprocal is equal to 1. So this is going to be B. And on the right-hand side, I have to multiply this out. Well, this is really just 5,500 times 3. So this is 0, 0, 15, carry the 1, 15, 16. So it looks like it's going to be $16,500. So that was the original, right, sales bonus. And then 1/3 of that was the 5,500 that was invested in the stock market. Okay, let's do a few more MyOpen math problems, and then that'll be it for this section. Okay, so here's just a couple of straightforward questions where we want to solve for the unknown variable. So in this first example, I have 48 is equal to 8b, and I want to solve it for b. Okay, so again, if you want, you could write it like this, right? I could write it as 8b equals 48. It doesn't matter what side I put that variable on. Now, since b is being multiplied by 8, to undo that, to give me a 1b, to isolate the b, I can divide by 8, right? But whatever you do to one side, I have to do to the other side. So these cancel now. I'm going to get 1b, which is b. And then 48 divided by 8 is, of course, 6. So that would be my answer. So b is equal to 6. In this question, I have q divided by 3 is equal to 6. So again, to get one q, right, to isolate the q, I can multiply by 3, right? It's being divided by 3. If you want, you can think of this really means 1/3 q is equal to 6. So remember, when the unknown is being multiplied by a fraction, to undo that, to get a 1 there, I just multiply it by the reciprocal, right? 3/1. So this is going to be 3/1. So q in this case is going to be 6 times 3, which is 18. That's going to be 18. And notice if we can check it, right? If we plug it back in, well, 18 divided by 3 is 6. So 6 equals 6, right? That checks. And we'll do one more. Let's say we have solve 20 is equal to 5w. Here, this time I'll leave the variable on the right-hand side. Right, again, it doesn't matter. Since w is being multiplied by 5, and we want to get a 1w, then to undo the multiplication, I can divide by 5, right? But whatever I do to one side, I have to do the other side. So 20 divided by 5 is 4. And of course, on the right-hand side, I now have w, which is what I want, right? The 5's cancel. And that's my answer, right? And of course, I could write it like this. I could just switch what side of the equal sign each expression is on. So w is equal to 4. And that makes sense, right? If we plug back in, 5 times 4 gives me 20. So that checks. All right, great. So that's it for, that's it for Module 4 on basic algebraic equations. And next module we'll look at is Module 5, which will start looking at ratios and proportions. Great, thanks.